now that we maybe know just enough to be dangerous about chemical reactions, describing them in terms using a chemical equation, balancing that chemical equation. We talked about stoichiometry of the chemical equation, going from the amount of something to the amount of something else. And then most recently we talked about solutions in general, and then one way to describe solution concentration is molarity. Now we can actually do this last type of problem in this unit that deals with aqueous solution stoichiometry. So we're kind of bringing it all together. And the reason we can do this sort of problem, or I should say at the crux of aqueous solution stoichiometric calculations, is the definition of molarity is moles of solute per liter of solution. And maybe you've done this in algebra, but if you know two of those quantities, you can calculate the third. So that's to say, if, for instance, you know molarity and moles of solute, you can get to liters of solution. Let me do some little check marks up there. So if you know this and this, you can get to this. Molarity and moles of solute, you get to liter of solution. And you guys have done problems like that. If you know moles of solute and liter of solution, or volume of solution, by golly, you can get to molarity. And I guess the last one, I'll pick up a blue pen here. If you know, which one didn't I do? If you know molarity and volume, you can get to moles of solute. And you've been doing those problems, and I'll show you what that looks like. So we're just going to kind of jump in there and do a problem. Let's say that you're faced with this situation, this question. So someone's gone ahead and balanced this, given you the balanced chemical equation for a reaction. And I'm just going to go ahead down to the bottom here. I'm going to write some information. So it's what volume of 0.235 molar NaOH. So I'm going to find my NaOH, and I'm going to write question mark volume. And also I know the molarity of that NaOH, 0.235 molar. And if I write it underneath the species, then I have it organized. And then the problem goes on to say, what we better have some more information, is needed to react with 35 milliliters of 0.10 molar H2SO4. So I'm going to find my H2SO4, and I'm going to write my 35 milliliters, 35.0 milliliters. Don't forget those trailing zeros after the decimal, guys. And the molarity of the H2SO4 is 0.108 molar. Now, in working this sort of problem, do you see where of these two things, H2SO4 and NaOH, that I know anything about, I know more about the H2SO4. So I'm a pictures person, and I don't think about it too much. I just kind of throw the information, like I said, under this balanced equation. And can you see where my step number one actually is I can get to moles of H2SO4 using the molarity and the volume. We've done that before. And then if I have moles of H2SO4, can you see where, I'll go ahead and say moles of H2SO4, I'll go say using milliliters and molarity. And do you see once I have moles of H2SO4, then I can get to moles of the other thing, which in this case is NaOH. And I can do that using stoichiometric ratio. So we're kind of combining a few things. I'm on my way to get to volume of NaOH. So now do you see where if I have moles of NaOH, I can get to volume of NaOH using the moles I just came up with and the molarity that was given. Okay, so I'll kind of show you how this works. Okay, so kind of what we do with this sort of problem is we have two solution problems that are bracketing those solution problems are bracketing a stoichiometric calculation. Okay, and that's kind of the pattern that these take on. You're going to actually see me do 3 separate problems to kind of get to my answer over here. So, just to kind of summarize, the 3 steps we came up with were: the first step, we know more about the H2SO4. We can get to moles of H2SO4 from the volume and molarity. The second step is we can get from moles then, we can get to moles of H2SO4 from volume and molarity. Once we have moles of H2SO4, we can get to moles of NaOH using a stoichiometric ratio. These are going to be 3 separate problems for me. And then the third problem is, once we have moles of NaOH, in this case we can use molarity of NaOH to get to volume. So here we go. Now if you label the steps, I think that's a good thing, especially if, to me, and on my answer keys I'll usually do this, when I label what the species is, then I don't have to include it in my problem. So for instance, the first step is to get moles of H2SO4, and actually I might just stop with that as being my label. And then remember that we were given volume and molarity. So we've done this before. To get to moles from volume and molarity, I like to start with volume, but you could start with molarity too. Molarity is, hopefully this is ringing some bells. We said you can unpack this to mean 0.108 moles of H2SO4 per what? 1 liter of solution. Okay, so you can feel free to unpack that in the margins somewhere. So my point was that I got this volume thing going, but notice that I have to go from milliliters to liters. So what's my next term going to be? Yep, it's going to be 1 liter solution over 1,000 milliliters. Now what would the third term be here to go ahead and make to make liters of solution cancel and be left with moles? Yep, we can use molarity here, 0.108 moles of H2SO4 per 1 liter of solution. So what we've done here, like I said, we were after moles of H2SO4. Milliliters cancel, liters of solution cancel, we have moles of H2SO4, which is great. Now we're going to use that as the starting point in our next little calculation. That next stop is the stoichiometric ratio. Oops, sorry. I didn't finish this thought. I get so excited about the units I forget to plug it in my calculator. So can you see where we've rounded it to 3 significant figures here? Because don't forget, we have 3 here, no uncertainty brought here, we have 3 here, so this is 3 sig figs here. Alright, now we're going to use that as our starting point to get to moles of NaOH. So don't make it harder than it is. Now what would this stoichiometric ratio look like here? I'll do a little circle here. Okay, can you think of a stoichiometric ratio that will leave us with units of moles of NaOH? Yep. Do you guys see where those coefficients came from? We're going with 2 moles of NaOH. There's 2 moles of NaOH over, we get this from the balanced equation, don't we? From stoichiometric coefficient from the balanced equation. 1 mole of H2SO4. Very good. How many sig figs we allow in this answer? Very good. 3 sig figs again. So 0.00756 moles of NaOH must be what we're looking at here in this situation. So the third thing, and the third thing kind of varies from problem to problem, but in this case we were given molarity, and now we have moles, and we're going to use moles and molarity to get to volume. Okay, so notice how I have titles on each of these 3 different parts. So we're piggybacking on the moles of NaOH that we got from the previous calculation, 0.00756 moles of NaOH. Now what is our next term going to be? We're actually going to use the molarity of NaOH. So go back and let's see if I can find it in my notes right quick. The molarity of NaOH was, I got molarity of NaOH is 0.235, and I will go ahead and unpack that. It means 0.235 moles of NaOH, per 1 liter of solution. Okay, so tell me how you can use this, put it right here as our next term, to go ahead, to go ahead and let moles of NaOH cancel, be left with liters of solution. Hopefully you said this. It's what I call the flipped version of the molarity of NaOH. Hope that works for you. And I can double check, but I think I'm going to take this all the way. That will give us liters of solution, which honestly you should be able to, I can't remember if I explicitly wanted milliliters or liters. Sometimes you can go ahead and stop there. But what would be my last term here to make liters of solution cancel, be left with milliliters of solution? Yep, 1,000 milliliters of solution on top over 1 liter of solution. Now again, it's all about, we've been talking about this throughout the semester, it's all about the units canceling. Okay, so to me, I have units of milliliters of solution, which is perfect. How do I need to round this answer? I'm liking 3 sig figs. So 32.3 milliliters is the volume of that NaOH that you would need with that molarity of NaOH to react with that volume and molarity of the H2SO4.